Our last two parent graphs or base graphs are going to be absolute value of x, and I will tell you, we use absolute value of x a lot. You're going to see this one a lot. And the parent graph 1 over x, which we call the reciprocal function, I'll be honest, we won't see this one very often. You will need to know it as a parent or base graph, but we probably won't do much shifting with it. We'll hold off until unit 3 and we'll talk about it as the reciprocal function. But let's look at absolute value of x. So remember, the absolute value of any number, so the absolute value of it just makes it positive. So the absolute value of 2 is 2. The absolute value of negative 2 is also positive 2. So we went through our t-table and we made all of these points. And again, notice our base points are going to come from 1, 0, and negative 1 for the x. And the answers, when we plug those in, are 1, 0, and positive 1. But as opposed to the parabola, which has the same parent graphs, you'll notice that what happens here is that we get these nice straight lines that are going just straight through the diagonal, and it looks very, very straight. So if you asked a kindergartner, what letter is this? They'd go, that's a V. As opposed to when we were back on the parabola, you can see it's curvy, it's going up faster. We're going to call that one a letter U. Here's the kicker. If you draw me a parabola and it's straight, then it's going to be wrong. You got to get the little curve in at the bottom, right? Parabolas are curvy at the bottom. Absolute values look more like those straight-sided V's. The other, also let's go ahead and look. You can see here's a you can see straight as an arrow right through the diagonal. This is what an absolute value graph would look like if a computer graphed it. And let me just put in the x squared. You see very different, skinnier, goes up a little bit faster. It goes through those same points, but there's much more curve involved in them, right? So we need to sort of understand the difference between the two. Okay, our last function is the reciprocal function. And basically what it does is it just flips all of our numbers upside down. So if you plug in a 2, it's going to give me 1 over 2 or 1/2. Plug in a 1, well, 1 over 1 is 1. If you plug in a negative 2, well, 1 over negative 2 is negative 1/2. And what's really weird is, like, if you plug in a 1/2, if x is 1/2, what's the reciprocal of that? It's going to give you a 2. So what happens is we get kind of these funky looking things. But I notice I've kind of ignored 0 here. So let's think about 0. What happens if we flip that over and we do 1 over 0? What's wrong with that? Right, you can't divide by 0. So we've seen that already several times this year. So that gives us that does not exist. Oh, now you silly computer. So that gives us that does not exist moment, right? So there's actually no dot at 0, 0, which is the first one of our graphs to not have a dot at 0, 0. And instead what comes up are what are called asymptotes. So the x-axis and the y-axis become asymptotes. Remember, those are things where the graph is going to get really close to them but never quite touch them. And then we're going to get sort of this curvy looking graph on the upper quadrant, the positive quadrant, and we're going to get a curvy looking graph that gets closer and closer to the asymptotes on the negative quadrant. So we get sort of this picture. It's really hard to draw this, so I'm going to go ahead and let Desmos do it. So let's go ahead and get rid of all these base points and just give you sort of a generic picture of what this looks like. So do notice it goes through 1, 1 and negative 1, 1. But notice, is it touching the x-axis and the y-axis? No, it never does. It's going to continue to get closer, but it's never going to actually touch it. So we've got those asymptotes, and our only base points are 1, 1 and negative